Now we'll go into the CO2 inventory calculation. So in CMG we have a keyword called inventory CO2. If we This is an optional keyword, and if we put this in, it will actually activate the CO2 inventory calculation, and it will write the inventory table in the main output file. Now if you want to see the same thing in the results, then there's some optional keywords that you need to include in your data file, and now then you can output the same thing in results file as well. So in inventory table we will see how CO2 is stored in forms of in various forms like gas, liquid, trapped, supercritical, soluble, aqueous components, and minerals. So now this keyword has two sub keywords, total and net. Now if we put in total, then the CO2 inventory table, it will actually include the CO2 initially existing in the reservoir. So when you initialize, even though you are not injecting, there might be some initial presence of CO2. And if you put in the net keyword, then it will exclude the initial in place CO2. Then it will just show the what CO2 is you are injecting. So if you don't put in any sub keyword, by default it will always assume the total. So now let's take a look at it, how it looks like in the actual data set. Now as we are looking at this example here, so now, right now during the first time step here in this particular data set, we don't have a sub keyword, so by default it is assuming inventory CO2 total. And because of that, in the first time step we don't inject anything or produce anything, even though we see CO2 being stored in different forms during the initialization. So this shows the presence of CO2 at the initialization, and during the last time step we are looking at the same CO2 inventory table, and we can see we have injected this much amount of CO2 here, and this is our updated values of CO2 stored under different forms. So now the common question that we get from a lot of client is when they want to actually double check their cumulative injected CO2 and how it's stored, they actually try to compare this value with the summation of this table. So here we need to consider two things. First of all, CO2 trapped or CO2 due to hysteresis, that is already being considered in supercritical CO2 in supercritical phase. So when you are actually matching numbers, we need to ignore this line as it's already being accounted in for CO2 in supercritical phase. So, and the second thing that we need to consider is we can't just take summation of those four numbers here, as there is some amount of CO2 initially present and we did not use the CO2 inventory CO2 net keyword, and because of that these numbers are already accounted in here. So we need to look at the delta here. So because of that, this is the formula that we should use if we are using inventory CO2 total keyword. And here this is the table that CO2 in four different forms for this particular example. At initialization these were the numbers, and after 1,000 years of simulation this is the updated numbers that they have. And right now we are looking at the difference between those two values, and you need to sum these differences up, and now this number we can compare it with the total cumulative injected, and we can see that it's similar. So this is how we can double check that how our injected CO2 is stored under different forms. This is again the 2D plot of different forms of CO2, and here we can see with time the highest amount of CO2 is being stored as a CO2 in supercritical as this line, and we can see during our injection period we see that it actually increased quite significantly. Here for all other kind of CO2 storage like CO2 trapped or CO2 dissolved or CO2 in aqueous ion, that we see that those actually increase during injection, and then they keep on increasing a bit as CO2 plume migrates in the reservoir. Now for CO2 in minerals, as we can see even during this orange line during the initialization, we see actually decrease in CO2 in mineral form, as there might be some initially mineral presence in our reservoir, and those might be being consumed when we are injecting CO2, but overall with time we see that CO2 in mineral is actually increasing. Here we can see that the scale of CO2 in mineral is different, then it's actually very smaller than CO2 in other different forms. Now let's take a look how the same plot looks in results and how we can actually use this in the dashboard. So right now we are looking at the same results file. Now we are looking at the dashboard called trapping mechanism, and here we are looking at the same plot that we just discussed in our PowerPoint, but we can actually add this plot along with the different IK or aerial or JK view, and we can actually see parallel how those CO2 stored in different form actually looks like. So here this is CO2 formed in mineral at the end of our simulation. So we can see that around the wellbore we see some of the CO2 being precipitated as mineral. Here we are looking at the CO2 because of the hysteresis. So we can actually run this and see that dynamically, that how CO2 in minerals or CO2 due to hysteresis is actually formed. So dashboard is pretty important feature in our results, and this was and I think this is the end of our presentation for CO2 plume visualization and inventory calculations. Thank you everyone.